trying to do here is solve trig equations. And I'll jump right in. Let's do this one. Did I do 7 last time? Did I do a quadratic, like 2 sine squared plus sine plus 1? Okay, so what we're going to do this time is a version equation 8. And we're going to solve that guy. And they're telling us that our starting theta has to be inside the unit circle, which is fine. And we are going to try and create all the solutions to this one. And this is the first time we've hit a 2x, right? Everything's always been cosine x or sine x or maybe tan x. But this is the first time we're going to hit this guy. So it's going to start off really quite simply. Right? If I take the inverse cosine of both sides, won't I get 2x equals this guy? Great. Now, if we go to our unit circle and we find an x coordinate of 0, and would you agree the answer you get is, I'll put it over here, is pi over 2. You agree? Where else would you get an x coordinate of 0?
3 pi over 2.
Okay, so now, there are actually going to be 4 answers, but here are 2. If you divide this by 2, do you see you get pi over 4? And if you divide this by 2, you get 3/4 pi. Now, our starting numbers are 0 to 2 pi, but let me finish this guy off. We're going to do that to 2 pi k thing. Okay, that's that answer done. And then we're just going to add on 2 pi k, which is that guy. But that's only 2 answers. And typically that's what you would expect. If that was x, you'd only get 2 answers and you'd be happy. But it's 2x, which means that there are now 2 more answers where x is between 0 and 2 pi. And that's where it gets a little bit sneaky. Right, let's go back to this guy. You agree pi upon 2 works. If I went around the entire circle and back to there, wouldn't I get 5/2 pi? Would you agree if you went round the circle and back again? Now you might say, but that is not in the unit circle, but this is the guy that needs to be in the unit circle. And isn't 5/4 inside the unit circle, right? It's not that 2x needs to be in the unit circle. It's that the x's need to be in the unit circle. And so there is our third answer. So who's the last one? Because I said there's 4 answers. Well, remember the guy that was down there? 3/2? If I went round the entire circle and then went to 3/2, you would end up with that guy plus another 2. You'd end up with 7/2 pi. And that would then get you 7/4 pi. And that is inside the unit circle. So there is your final answer. Are you okay with that little weird thing that you have to do when it's 2 x's? Right. Now, if this had been, say again?
Sorry, I can't see very well. Is that x equals to 7/4 pi?
Yes.
Okay, thank you.
So,
sorry.
No, my writing's not great, especially when it's a squashed the corner. So there's our first answer. That was the second one. That was the third one. And last, there you go. So those are the 4 answers that we got to that trig equation. Now, suppose this, to try and just show you the idea, suppose the only difference I do to this question is I make this the cosine of 3x equals 0, right? So I'm going to do another one of these, almost identical, and show you, again, you've got this. You know, if they were really good, wouldn't they tell you that, wouldn't they use the variable that's there? But that's just WebAssign being weird. So 3x is the inverse cosine of 0. And that would get me 3x is pi upon 2. And 3x is 3 upon 2 pi. And if I did this one, x ends up being pi upon 6. If I did this one, x equals, divided up by 3, is a half pi. Now, what would the next one be? Well, wouldn't you take this guy and add a circle's worth, which is 2 pi? So you get 5 halves pi, and that gets you 5/6 pi. And then you take this one and add another circle's worth, which would get you 7 halves pi, which means you get 7/6 pi. Could I do any more? Could I squeeze in a few more solutions this time? All these answers are inside the 0 to 2 pi, right? Every single one of these. What would the next? There are actually only 2 more. What would the next one be? I did this guy and I added 2 pi to get this guy. Instead of adding 2 pi, couldn't I go and add 4 pi, right? Just keep on going round the circle until, you know, I don't need to do it anymore. So if you go round that, you get 4, you get 9 halves pi, and that gets you 3 halves pi. And then the one I don't have room for would be down at the bottom. If you took this guy and went around the circle once and then one more, that would be 4 pi worth. You'd get 11 halves pi, and that would get you 11/6 pi. And whoa, there's 1, 2, 3, 4, 5, 6 solutions. Now, I'm not going to do cosine 4x, but can you imagine I did cosine 4x when I end up with 8 solutions? And cosine 10x, I'd end up with 20, right? Now, nobody would expect that because there are too many answers. So that's how you deal with multiple x's. You get the usual answers, and then you add 2 pi to them to get some more answers. And then you add 2 pi to them to get some more answers. And you keep doing that until your answers end up being bigger than 2 pi. If I did one more, can you trust me the answers end up being bigger than, you know, 2 pi, and so I can't use them?
I have a question.
Yes.
So wouldn't there be unlimited answers for this? So it would be just x equals 6 pi over 6 plus 2k pi.
Yeah, all
Wouldn't
of them
that
get
also
that.
get you the 5/6 pi?
And did that give you the 5/6 pi?
And it would also get you the 11.
If it did, then
11/9/6
I wouldn't
pi.
use them. You're right. If it did, I wouldn't use them.
Because it's
'Cause
just a
that-
multiple of 2 pi. So wouldn't all of those, the 5/6 pi and then the 3/6, the 11/6 pi is all going to be still multiple of
Yeah.
1/2 pi, right?
You're quite right. Only WebAssign wants you to do all of them, even although there are duplicates. What he's saying is, look, if you add 2 pi to that, you just get one of the other ones, right? That's what I'm hearing you say.
Right.
Right. But if you add 2 pi to that, you don't get 11/6. You get 13/6.
No,
So
you get
you-
11/6 if you add to 1/2 pi, don't you?
If you add 1/2 pi to who?
The 2 pi to 2 pi k.
Right. So if you
You'll
add
eventually
2
get
pi,
11/6 pi.
right, if you add 2 pi to that guy, you get 5 halves pi. It's none of these answers. Are you saying you'd get a multiple of one of the other earlier ones? Which is what I thought. That's what I thought you were saying. Yeah, you would eventually get multiples of each if you kept on adding it. But each one of these is kind of unique to themselves. I can't get this answer and get one of these by adding 2 pi. Don't add 2 pi up there, add 2 pi here. That's what we're saying.
Oh, okay.
Right. Now, if you take these answers, if you add 2 pi to any of these, you won't get any of these answers. Right? They are unique in that sense. But I mean, if you add enough, you get versions of the same guy. God, that was a weird one, wasn't it? Well, I'm not finished with the weird ones because there's 2 more of these kind of special situations. This one is different. We're trying to solve this guy. And it's got that usual 0 less than or equal to theta less than 2 pi thing going on. First time you've seen that guy. As long as you do it to both sides, it's okay roll. This question is not even going to have a sine or a cosine in it when I'm finished. This equation is going to turn into another trig function equation. Can anybody see something that you could divide both sides by that would change the look of this equation so that we only have 1 trig ratio to deal with instead of 2?
Turn it into
Divide both sides by cosine, and then you get a tangent.
Yeah. So if you ever get a question where it's sines equals cosine, you know, this kind of thing, divide both sides by cosine. Now, sine over cosine gives me tan. And it's equal to 9, right? And then you can divide both sides by 4. And I know that's not in a unit circle, but that's okay because they went and said in this question, give your answer, whatever it is, to 5 decimal places. So x is simply just going to be the inverse tan of 9/4. And they want it in radians. So I'm going up here and I'm going to go inverse tan of 9/4. And what was it, 5 decimal places? 1.15257. And they also tell you in this question that they want the answer in the form that looks like that. So we're just going to call it 1.15257 plus pi k. So in a lot of ways, that was much easier than the usual. And there are 2 boxes, but the second one is none. And you might say, why don't I have a second answer? Well, here goes. If you do a tangent that's positive, all sine, tan, cos, the answer, this one here, is over here in the first quadrant. The other answer would be over here, right, in the third quadrant. Great. But since you're only allowed to pick angles, oh, I'm going to make myself wrong, but I'm going to fix it. This guy is allowed, yes, but if you add pi to that, don't you get this guy anyway? So he's included in there. So just to be awkward, have you noticed that WebAssign is breaking their own rules of having separate answers both with pi k, and in this case, they're saying that answer, if you add pi k, gets you to the second one. That's not very convincing.
Adding pi k, how does that work out?
Well, you make k equals 1, so you would, here's part B, which actually will help. The first answer we got is 1.115257, right? Now, if you add 1k, you get 1.15257 plus 1 pi. If you do it again, you get 1.15257, add 2 pi, And if you do it again, you get the same decimal, add 3 pi. Can you keep doing that forever and get a slightly different answer each time? Right. Now, if you do that in your calculator, I'm just looking at their numbers, you're going to get 4.29416. And in question B, which is what this is, they ask you to write down all the solutions, but only the ones that are in the range 0 to 2 pi. So if I did this one, can you trust me, the answer is bigger than 6.3, so it's bigger than pi. So that one doesn't get used and that one doesn't get used. So you will have one solution. There's that one in the third quadrant I was talking about that I didn't need to write because this includes it. And then the other two, because they're too big, you're going to write none again. Now, if they'd said 0 to 4 pi, I would have added what these two are. And if they'd said 0 to pi, I would only have used that one, right? So whatever they tell me the range is, I can only use numbers where the angle is in this particular range, whatever that might be. Okay, slightly unsatisfying, but it is what it is. So now the next one I like, because it's graphical and I like visual things. We are going to draw using Desmos, that function, and that function. And once we've drawn them, that's part A, we're going to use that graph to do part B, and that's find the points of intersection. So essentially, we're looking for when is f of x crosses and equals g of x. So this is not clunky, this is nice and smooth. So bear with me for a second while I find the right window. That looks good. And here goes. Sine, basic, Desmos. Right, the first one is y equals the sine of 2x. Nothing very surprising about that one. Y equals 2 sine x plus 1. I'm going to double check that question because I got a feeling there's more to it than that. Sine 2x, okay, that makes a difference, I guess. There we go. That looks better. Now, one of the pictures that you've got is going to be similar to that, but in this particular question, let me move this somewhere where I can see it all the time. There we go. Right, are you looking at the graph? Is that what you can see, guys? Are you seeing it? Okay, that's good. Now, they ask us to graph it, and there's 4 pictures, and one of them looks like that guy, and that's fine. And they're only interested in the range 0 to 2 pi. So I'm going to go, and I'm going to tweak this guy. Wrong button. Tweak this guy. And I'm going to do 0 to 2 pi. Yeah. There. Now, intersections happen, right? When the first one and the second one touches. If I move this a little bit, can you see there's an intersection here? See it? Here. And can you see the answer is x is 3/4 pi? And there'll be another one over here. And there we go, 7/4 pi. So Desmos is really nice because it could have gave me 2.133 and some ridiculous answer. But you see, it's quite nice. As long as the places are like on your unit circle, it'll find them. And that's the end of that question. So draw two graphs, find out where they intersect. I'm just want to play about with this because I can. Why don't I make this one take away 1? There. Okay. And why don't I make this a half? There. Now, if I click on that guy, can you see the answer is 13/12 pi? I was just wondering, it's actually cleverer than I thought. It won't just take a third pi, it'll take 7/12 and some other weird fractions. But that would be the answer. Now, do you know some of the earlier questions that we were doing, where you were trying to solve an equation? Can I find one? No, I probably threw it away. Yeah, remember the cosine 2x equals 0 one? I'm going to go here and show you how you can use Desmos to check it. There is the cosine of 2x guy. And if you're looking at when it's 0, aren't you essentially interested in that guy, that guy, that guy, and that guy? Can you see our 4 answers now? And do you see in the range 0 to 2 pi, there are 4 answers. You see why that one has those solutions. Now, I can't remember what the other one was. I think it didn't work. The other one was a decimal one, wasn't it? Yeah, that one won't work so well. Okay. So far, so good. Right. Well, we are not finished with solving the equations. And believe it or not, that was set 1, which was meant to be the easier ones. And you're thinking, they can get harder? Yep, they can get harder. So let's look at 7-4 now. Set 2. You ever watched those horror movies? I don't like horror movies much, but I watch them. Yeah, and you watch those horror movies, and at the end, or 10 minutes before the end, the head vampire is dead, or the zombie was killed, or whatever it was that was eating everybody is dead. And they all go, oh, that was good, we're okay. And they're walking away, and as they're walking away, one of the monsters digs out the ground and you see a hand moving so that they can do a sequel. This is like that. You fought your way through a horrible trig with monster equations, right? And some of them have made you real scared the heck out of you. And you thought, phew. And just as you're walking away, set 2 pops up. So let's see what set 2 adds to the mixture that makes your life even scarier. Well, here is the first question. We're being asked to solve sin x equals 0.7, and we're going to do it graphically. And we are picking x's in this question in that range.
We're not looking at your paper, by the way.
Oh, sorry. Thanks for telling me. Here we go. So, totally different kind of equation. I am not going to solve that algebraically. I'm going to find every solution in this range, and we're going to do it using Desmos. So this question is not actually too bad. So where's Desmos? I've lost my Desmos. Come on, Desmos, where are you hiding? Gotcha. Okay. So the answers are not going to be nice numbers, and that's okay. I think that the answers are like the 3 decimal places, right? So you go over here and you put in sin x. and then you go here and you put what you want it to be equal to. So that's the simplest way of setting this question up. So now I go over here and I make sure that the x-axis is from -3. If you type in the letters pi, you get pi, and finishes at 3 pi. Right. Now, as long as it's in this window here, it's a solution. So if I look at it, would you agree there's a solution here, there's one here, there's one here, there's one here, I think I killed that one here, and lastly, one here. Do you see the answers are the x coordinates? So you would be writing down -5.508, which is that one. You'd be using as the next one, -3.917. I'm not doing them all, but if you did that last one, which is kind of here, I'm going to have to move it to see it. 8.646. 649. Are you comfortable that that wasn't actually that bad, right? You plug it in, you get lots of answers. Now, if the answers were meant to be to 3 decimal places, then we are totally okay. But they don't want the answer to 3, they want the answer to 4. And unless someone can tell me how to make Desmos give a more accurate answer, I'm going to have to show you a backup plan. I don't like using my TI-84 for these kind of questions because I like Desmos, it's big and it's colorful, but we can do it. Make sure that you are in radians. Type in y equals sine x and type in 0.7. Choose your window, make this guy -3 pi, make this guy 3 pi, and then just do zoom 0 and zoom to fit. And you will see the first guy and then a horizontal line, right? Pretty much like a miniature version of what Desmos did. Now, the advantage, and probably the only advantage that Desmos has got, is you can get a more accurate answer. So let's just find that one there, right? The first one. So it's going to be second calc, number 5 intersection. And I'm moving my little cursor. Which is there. And it's asking first curve, so I put enter. Second one, put answer. It says guess bit, etc. And the answer is now -5.507788. You see, it's the same answer, just more accurate. So if they want the answer to 3 decimal places, Desmos will do it. If you need more, you're going to have to go to your TI-84, which is a little bit messier, but it'll do it. And that was our first monster. Wasn't too bad. Next question. You're going to use your graphing calculator to find the sign of that guy. And you're going to do it to 2 decimal places. To save time, can you pretend that I've went to Desmos, and because it is 2 decimal places, I can use it. And I got that answer, and the other answer I got was that one. And this time we're only interested in, the 0 to 2 pi range, right? So solve this equation in the 0 to 2 pi range. Desmos told me that guy, and Desmos told me that guy. So far, so good. And then part B, give me all the solutions. You bring in that 2 pi k guy, that 2 pi k guy. So Desmos, all the solutions. Have you wondered why it's 2 pi k and not pi k or 6 pi k? Have you ever wondered why this is 2 pi and not some other multiple? What is the period of sine x?
2 pi.
2 pi.
So is that why when we're working with tangent, it's plus pi?
It's
Okay.
exactly that. Yeah.
Okay. That makes
So-
sense. That's what I was wondering earlier, but that, okay.
That's the reason. So if I was doing, I'm making this up, but pretend the answer was nothing 0.713, you do pi k. And when you do a tangent, you only need to find one of them, because see the other one, you get him for free, because when you add a pi, you get the second answer automatically. So tangent's a bit, weird. So let's up the ante and do this one.
I have a question.
Yes.
So is it just the period plus k then, or period times k? Is that what you're doing, is adding?
All I'm doing is adding multiples of pi. So 1 pi, 2 pi, 3 pi. And here I'm
Okay.
adding multiples of 2 pi, right? So add 2 pi, add 4, add 6, or take away also works. Right, let's try this guy. The sine of x is going to be 0.5, right? And so I could go to Desmos, couldn't I? And I could find the solutions, right? So that's where I'm off to right now. Again, I'm having that issue of which window am I meant to have open. Okay, ready to show you. We are going to find all the solutions to the sine of 3x equals 0.5. So in here, oh, wait a minute. I don't even know what you're looking at. There, you're looking at Desmos. So I'm going to put, eventually, there's the sine of 3x, and it's going to equal 0.5, which is nice. And I'm only interested this time, I'm only going to be looking at 0 to 2 pi. Okay. Now, if I click on that answer, can I get, oh, good. Do you see that the answer there is that x is pi over 18? Do you see that one? Now, if I move along, do you see I'll get a second answer here, a third answer here, a fourth answer here, a fifth answer here, and a sixth answer here. If this says sine of 3x, you will typically get twice the number of x's. So if it's 3x, you'll get 6 solutions. If it's 2x, you would get 4 solutions, and so on. So there is one of them. I'm just going to write down 2 of them. Altogether, there's 6, but I'm only writing the first 2 because I don't want to write all of them. That's the only reason. And if the question had been to write all the solutions from 0 to 2 pi, wouldn't you just write down all 6 of them, right? But if they want you to do all solutions, right, infinite solutions, what is the period of 3x? Been a while. How do you calculate the period of the sine of 3x?
Is it 2 pi over 3?
Okay. So when you want to do all the solutions, can you see why you add 2/3 pi k to each of the individual solutions? Does that make sense? Why this has now changed from 2 pi k to 2/3 pi? The general formula really is this. It's the solution, whatever that is, plus the period times k. So if the individual solution is that guy and the period is that guy, do you see? Is that making sense where the pieces are coming from? I'm looking at a worried face here, or maybe it's a thinking face. Matthew, what are you seeing here? Is that making sense?
Those are making sense. I'm just trying
You're
to
thinking,
mentally.
right?
Yeah.
Nothing wrong. You're processing it. Nothing wrong with that. So this is why this is set to, right? There's lots of, you have to deal with something a little bit messier than it was in the previous question. So here is version 3. Question 3, I should say. And in question 3, we are being asked to find all the solutions of sine theta equals -1/2. Now, to save time, can I tell you that if you go into Desmos and you do the picture, you could actually get this from the unit circle, but will you trust me that the answer is 7/6 pi according to them and 11/6 pi? Does that seem reasonable that that would be the answer, right? Now, what is the period of sine theta?
2 pi.
So that's why the infinite solutions look like that. Are we good with that? Now I'm going to do a version of 3 that is the ugly version. All I'm going to do is that, right? Now, when I do this, how many solutions do you think Desmos is going to have before we even go and look at it? We are going to look at it in a minute. But well, I've wrote them down. You should never tell your students a question when you've got the answer in front of you. There's going to be 4 of them, right? But if I hadn't shown you that, would you realize that 2 thetas get you 4 solutions and 3 thetas tend to get you 6, right? Okay, so there are going to be 4 solutions. What is the period of the sine of 2 theta?
Pi.
So when I get whatever that solution is, aren't I just going to add a pi k to each of them? Are you comfortable with that? Period k, period k, period k. Period was 2 pi, 2 pi k, 2 pi k. Period was 2/3, 2/3 pi k. Right. So back to Desmos. Let's see if I'm right about there being 4 solutions. So the function we're going to do is sine 2 theta. I'm calling it 2. Oh, do you know that you can make theta appear in Desmos? Side issue here. Does anybody know how to get theta?
You just type it in.
Yeah. Yeah. And if you want it to look like the question, there it is, right? And we want this to be equal to -0.5. And I said there were 4 solutions. Would you agree? 1, 2, 3, 4. You agree that Desmos is really good at getting you nice answers. So the solutions we've got are 7/12. And the next one is what, 11/12 pi. The third one is 19/12. And lastly, 23/12. So I'll return to the screen, the whiteboard, and I'm going to add a little extra onto this. Right now we have 4 solutions. All of them are going to be add pi k. Sometimes this happens and sometimes this doesn't. If you add pi to this guy, right? Just do one of them, right? Pi times 1. If you add pi to this guy, don't you get this guy? 7/12 add a pi is 19/12. Does that make sense? And what happens to 11/12 if you add a pi to it? What do you get? You get this one. So those two aren't necessary, because aren't these two guys including these two in their answer? Does that make sense? So that you might have 4 solutions, but in some cases, 2 of them are inside the other general solutions, right? Which I can't remember who it was, but somebody earlier on was talking about that. Do you remember who you are? This is that's that situation I think you were talking about happening here, right? That this answer and this answer get you these two eventually.